All right, we're here talking today about arithmetic series. And so the first thing we need to know is, what is an arithmetic series? Well, an arithmetic series is simply the sum of an arithmetic sequence. So an arithmetic sequence could be something as simple as 2, 4, 6, 8, 10, 12, and so on. And a series basically means that we're going to add all of those terms together. Okay, so we're going to end up with some new notation here and things like that. But the first thing we're going to do is we're going to take a look at how to write a series in what we call summation notation. This is the new part in terms of some notation that you're going to see here. But the first thing we need is an explicit formula. In order to write in summation notation, we need an explicit formula. So we're going to take a look at this particular series right here. Okay? And so this series, 3 plus 5 plus 7 plus 9, it's obvious that you're adding 2 each time. And this is what we would call an arithmetic series. So our explicit formula says, again, a sub n equals a sub 1, the first term, plus the difference d times n minus 1. There's my first term 3. The difference is obviously 2. And I can either leave it like that or I can simplify it. Now for summation notation, it's usually simplified. So we're going to go ahead and distribute the 2 and combine some like terms here. So this is exactly what we did a couple of lessons ago. But now we want to write this in summation notation. So take a look at this. All right. Now if you actually count these terms up here, there's 12 terms up here. My explicit formula says to plug in, if I wanted to find the 15th term, plug in 15 for n, multiply it by 2, add 1, and I would get the 15th term. What this notation is doing is it's saying, look, we're going to take and we're going to sum, this symbol here is called a sigma. Okay, it means to add stuff up. All right, that's really all it means. It means to add stuff up. Well, what am I going to add up? I'm going to add up from n equals 1, so that's term number 1, a sub 1, all the way up to term number 12. Okay? So that's what the notation means. Okay? It basically means find the sum of all the terms when n is equal 1 to 12 using this formula. So if I were to plug in 1 here, I would get the first term 3, the second one 5, 7, and then I could easily add all these up. Now we're going to come up with a shorter way to do that, but that's essentially what this is asking you to do. All right? All right, so the sum of an arithmetic sequence. This one, it says actually expand the series and find the sum. So what this notation is saying is we're going to sum from term a sub 1 all the way to a sub 6, and this is the formula that we're going to use to find each of those terms. Okay? So I would start off by plugging 1 into here. 3 times 1 is 3, plus 5 is 8. I would do 2, and then 3 all the way up to 6. So that's essentially my formula right there, my explicit formula that we're seeing here. And so I would do a sub 1 plus a sub 2. If we plug each one of those in like I just did for 1, we would get these 6 terms here. So again, think about plugging in 4. 3 times 4 is 12. 12 plus 5 is 17. There's term number 4. So we could find all 6 of these terms, add them together, and we would say that the sum from 1 to 6 of 3n plus 5 is equal to 93. Easy, huh? All right? Problem is, what happens when we want to add a whole bunch of terms together? So take a look at this one, and I want you to add those up as quickly as you can. All right. So I'm going to add them up. If you were to add all these up, I think you get 55 if you were that quick. But I'm actually going to do it a little bit different. I'm going to take this first term and this last term, and I'm going to add those two guys together. And that's going to get me 11. And then I'm going to take 2 and 9, and I'm going to add those together, and that's going to give me 11. And then I'm going to take 3 and 8 and add those together because that's going to give me 11. You see where I'm going here? If I keep adding all the terms together, the first and the last, then the next first, the next last, I end up with 5 sets of 11. That's a little bit faster. All I have to do is multiply 5 times 11. Okay? But what if I wanted to do this with a bigger set? I want you to think about what it took to do this. I had 10 numbers to start off with. I ended up with exactly 5 sets of the first and the last. All right? What is the sum of the sequence of numbers from 1 to 100? Turn off the video if you want to think about it for a minute. All right, so I'm going to look again at the sum of the first and the last. That's 1 plus 100. Now in the last one, I actually added them all up. I did 2 and 9, I did 3 and 8. I don't want to do that because that's going to take me way too long. The question is, once I add these guys together, how many sets of 101 do I get? All right, how many sets would you get? Well, by peeling off the first and the last, I basically have half as many sets as I did numbers. Okay, so I end up with 50 sets of 101, and if I do 50 times
Alrighty then.
if I do 50 times 101, I get 50/50. All right? So what's the formula for adding an arithmetic sequence? So I want the first plus the last, and then I want to multiply it by half of the numbers that I had. So we end up with this formula here. This is for the sum of a finite arithmetic series. Finite means there's a countable number of terms. So I had 100 in the last one. I could have 3,864. I could have 7 billion. But I know how many are there. I can't do an infinite set. So this says S represents the sum. Okay? So S sub n is the sum of n terms. And by the way, this works with odd numbers of terms too. Think about that one. N is the number of terms. Okay? A sub 1, just like before, represents the first term. And A sub n represents your last term. All right? So let's check it out. It's example 5 says, I think I've got something here. There we go. Just a little easier to understand here other than the formula on the left. S sub n equals the number of terms divided by 2. Remember that was 100 divided by 2 was 50. First term plus last term. All right? Number 5 says find the sum of the arithmetic series. Okay? So we could generate all 8 terms here. It says find the sum. Remember, this is that sigma notation. It means find the sum of the first 8 terms in this series. All right? Now I could crank them all out. I could plug in 1, then 2, then 3, then 4, then 5, and it wouldn't take that long because there's only 8 of them. But that's okay. We don't want to do that. What we really want is the first term and the last term. And we already know that there's 8 terms because we're going from 1 to 8, right? Okay, so here we go. N is equal to 8. A sub 1, I'm going to plug in 1. I'm going to do the math in the formula right here. Negative 4 times 1 plus 3. A sub 8, plug in 8 for n, do the math, negative 29. And then I'm simply going to place them in my formula. The sum of 8 terms equals 8 over 2, so I've got 4 pairs, okay? And my first term was negative 1, my last term was negative 29. If you add those together, you get negative 30. So really what we're going to end up with is 4 sets of negative 30. That's what we've got here, ladies and gentlemen. And we get 100 and negative 120. All right? All right. So example number 6, find the sum of the given sequence. All right, so this time we're going from the sum from 5 to 30. You don't necessarily have to start at 1, okay? So the first thing we need is the first and the last, okay? This is the easy part because all I do is plug in n equals 5 and n equals 30, okay? So we're going to do that first. So here's my formula again, 3n plus 1. So I plug in 5 for the first term, multiply by 3, add 1, I get 16. I plug in 30 for the last term, multiply by 3, add 1, I get 91. There's my first and last. Now I need the number of terms in this series. So I need you to think about this super, super carefully. I'm starting at term 5 and I'm going all the way to term 30. How many terms do I have? Raise your hand if you said 24. Raise your hand if you said 25. Raise your hand if you said 26. If you said 26, you are correct. Think about this. The terms that are not included here, okay, I would imagine a lot of you said 25, but think about this. 5 is included, all right? This is important that you understand this. 5 is included. What's not included are terms 1, 2, 3, and 4. So really what I'm saying is I'm missing the first 4 out of 30 terms, which means that there's actually 26 terms here. We are excluding terms 1 through 4, which means I take 4 away from the top number. Okay, hopefully that makes sense. All right, so once we know that, all we got to do is plug in, and there's our formula, the sum of the 26 terms, 26 over 2, 16 plus 91, and you do a little bit of math in your calculator and you get 1391. All right? Okay, here we go. Oh, we're going to skip that one. Here we go. A couple more examples here and we'll be finished up. This one says, write the series in summation notation. Okay? Now, to do that, when it says write a series in summation notation, what I need to know is what is the explicit formula, okay? That's the formula that goes right next to that sigma sign. And I need to know how many terms. Now, if you look at my series over here, I've got -6, that's a sub 1, -2, 2, 6, and you can already probably start to figure out that we're adding 4 each time here. Okay, so that's the easy part about this one. We're going to add 4. That's my D value. And then instead of a sub 50 at the end here, I've got f of 50. So remember I showed you some other notation in one of the other lessons. So you can either use a sub n or you can use f of 50. Okay, either one works here. I'm going to go through this example using the function notation like this. All right, so I know that there's 50 terms because this is a sub 1 unless I'm told otherwise. This is always a sub 1. And it tells me that I'm going up to f of 50 or a sub 50. So I know that n is 50. We already talked about the d value being 4. I know that f of 1, so my first term is -6. Okay, that's f of 1, or you can think about it as a sub 1. What I need to do is I need to take this information and I need to write an explicit formula. Remember, your explicit formula is this guy. A sub n or f of n equals a sub 1 or f of 1 plus d times n minus 1. Okay? So all I have to do is plug in some stuff here. I know f of 1 is negative 6. I know d is 4. And since, let's see here, since we know that we're going to go, let's plug those guys in. Okay, so there we go. There it is. F of 1 is negative 6. D is 4. And remember, in an explicit formula, we don't plug in for n right away. We don't want to do that. So this 50th term right here, we don't even care about that yet. We're going to simplify this formula. If I distribute the 4 over here, I would get 4n minus 4. And then I would combine the like terms to get the minus 10 here. Okay? Now, this formula will find me any term in the sequence now. So if I said actually find me f sub 50, we could plug it in and do the math over here and find f sub 50. Okay? But this is the explicit formula that goes next to the sigma notation. So here's my sigma notation. Notice my formula here, 4n minus 10, 4n minus 10. That's easy, right? At the bottom of the sigma is what n value you started with. What did I start with? We started at a sub 1, and we're going to end at a sub 50. That's it. So if it says write it in summation notation, this is what you're looking for. Now it says find the sum of the first 50 terms. All right, so think about what you need for that. Turn off the video, try it on your own. Okay, so we're back, and we need to know what the 50th term is. Okay, remember our formula requires the first and the last term. We've already got the first, but we need the 50th. And because we have this explicit formula here, we can plug in 50 for n, do some math, and we end up with 190. There's my 50th term. Now we go to our sum formula. Remember this? The sum of 50 terms is equal to 50 over 2 times first plus last. And you do some math in your calculator and you get 4,600. Okay? One more here. All right. A 60-row theater has 10 seats in the first row. The second row has 11 seats. Each row has one more seat than the row in front of it. Okay? So if you had to, we could start drawing some of this out. You know, we could put 10 seats. So the first row has 10. We would call that A sub 1 is 10. The second row, A sub 2 is 11. The third row, A sub 3 is 12. And you kind of start to see where it goes from there. Let's see, it says there are 60 rows in the theater, and they want to know how many seats are in the theater. Well, for me to figure that out, I need the first row, the last row. So I need A sub 1 and A sub 60. And then I already know that the total number of rows is 60. So here we go. A sub 1 is 10. For me to find A sub 60, I need an explicit formula. So we start off, well, there's my 60. A sub n, we're not sure about 60, are we? So here we go. Explicit formula. We need to find an explicit formula so that we can plug in 60 here and here. Okay? So here we go. We know the first term's 10. We know the difference is 1. I didn't really need the 1 here, but I put it in anyway. And at the same time, I went ahead and dropped in 60 right here, because I might as well do the math right here. I plugged the right side into my calculator just like that, and I get 69. There's my first row, there's my last row. You know what to do now, right? Add them up and divide by half the number of rows, or excuse me, multiply by half the number of rows. And you get 2,370 seats. Okay? We'll see you on the next one.